Ladies and gentlemen, from Redding, California, this is your forensic chemistry class. Thank you. Yo. Yo. Yo, yo. Good to see you. So guys, let's do this one. This is a unit conversion factor. You have to use a unit conversion factor when you are doing your measurement lab. In any problem that you are going to do, any problem solving, what do you start with? You start with what problem is giving you, and you end with what problem asking you, right? So what I'm going to do, all the way on the left-hand side, I'm going to write what problem is giving you. All the way on the right-hand side, I'm going to write what problem asking. Yes? Here we go. Well, go guys. Do this one. Do this one. Guys, does this make sense to you? All you are doing, canceling grams, going to milliliter, you are using density as a conversion factor, yes? Does it make sense? You can use density as conversion factor to convert mass to volume or volume to mass. Does it make sense? Do you have any question? Great, thank you. Do you have any question? Go ahead. I'm going to define another property, another physical property. It's called specific gravity. Specific gravity is very simple. It's the ratio of density of any substance relative to water, density of water. So density of water is 1 gram per ml, right? And density of any substance is certain number in gram per ml. If I want the ratio, I divide density by density of water. Can I say the 2 units of grams per ml are going to cancel each other? Yes? So can I say, what do you get if you divide anything by 1? You get the same number. So can I say, really a specific gravity is numerically the same as density, except it's unitless, it's a ratio. It's unitless. So if I say I am 3 times older than you, there is no unit there, right? It's a ratio. That means how many times the density is larger than density of water, right? Unitless, yes? So can I say really a specific gravity is numerically identical to density, it's unitless. Cancel grams per ml from density, you get a specific gravity. Yes? You may say, how? Why? Are we crazy? Why do we even define a specific gravity when it is the same numerically, the same as density? Here is the reason. It's very easy to measure density of any solution using a hydrometer. If you take, suppose you want to measure density of urine. If you take it to a lab, they measure the density of urine. That tells you a lot about concentration of different substances in your urine. It's easy, just place hydrometer inside, see it's going to float, you can read the number, that's a specific gravity, write gram per ml, in front of it you have density. Quick measurement of density of liquid. You can measure density of Coke and use a table, decide how much sugar there is in the Coke. So you don't have to do sophisticated analysis. It's a quick way of getting information about the content of a mixture, especially solutions. Does this make sense? Do you have any question? Is this clear to you? All right, thank you, Trayvon, and go guys! Does this make sense? Yes. Numerically, specific gravity is the same as density, except it's unitless because it's a ratio. Ratio of density over density of water. Yes? Does this make sense? Do you have any question? Okay. Go, guys. Is it fair to say that if you have a specific gravity, you have density? It is fair to say that if you have density, you can use density as a conversion factor to convert mass to volume. So first convert the specific gravity to density, which is 1.8 gram per ml. By simply adding unit gram per ml, the specific gravity is converted to density. And if the ratio, if I use density as unit conversion factor, I have 50 grams, I want to cancel grams and go to milliliter. Every milliliter is 1.8 grams based on the density. You get milliliter. It's suggesting that all you have to do, take 52 times 1 divided by 1.8. Yes? Ask a question. Do you have any question? But I want you to know that this chapter is extremely important for the rest of semester. You are doing calculation all the time, unit conversion factor. Please choose one of these hours that you can go. You sit together. He is going to be helping you running a session, which is going to help you understand this chapter and future chapters. Please use all these resources. The college is spending money, resources to help you succeed. Please take advantage of this. Yes, sir, Dietz. Certainly. Yes, sir.
Would the 52 grams relate to the specific gravity, and which relates to the density?
Well, specific gravity is related to density, right?
Right, but do these which of these numbers relate to what you're speaking of, if I may?
Yes, 1.8 gram per ml.
Is the specific gravity?
Right, the specific gravity, 1.8, first of all, without unit. Place gram per ml in front of it, then you have density. Now I have density. The difference is unit. No unit, the specific gravity. Add the unit gram per ml, it's density. What is the meaning of density? It means every 1.8 grams of this object has a volume of 1 milliliter. So that's the conversion factor. Or you can say every 1 ml has a mass of 1.8 grams. Either one, they're all equal to 1. You can use them as unit conversion factor. Yes or no? Does it make sense, Sheriff?
It makes absolute.
Thank you. Those of you who are having problem understanding these problem solving, you have told me about math problem, please go to these hours. Please go to Science Learning Center. Please come to my office hours. This is the time that you can learn. Then you'll be doing very well for the rest of semester. Break that barrier that you think you can't do math. You can. Yes, you can. Yes, you can. Yes. Yes.
My question is, in the problem it says the mass is 52 grams.
Yes.
How do you get volume of 52?
Okay. The mass is 52 grams. You start with 52 grams. You want to go to volume. Unit of volume is milliliter. You say, I have to cancel grams. I write grams on the bottom. I have to convert to milliliter. I write that on the top. What is the relationship between milliliter and grams? Density. Every 1.8 grams is 1 ml. So use density as a conversion factor. Any other questions on this? Yes, dear.
When would density of water change?
Density of water is going to change. Number one, temperature. Who says temperature? Temperature. Other thing, if it has anything dissolved in it. Sugar dissolved, salt dissolved.
So it's one and less.
Yes, we are talking about freshly distilled water at a temperature of, I think, 14 degrees of Celsius. I think so. Or room temperature. Would anybody check? Let's see who can find out. Go on your